Welcome back to GeoMasters. Let's make geography simple, exciting, and easy to master. Ready to decode tropical cyclones? Imagine them as Big Brother Mizansi contestants, dramatic, unpredictable, and leaving a trail of chaos. Let's dive in before load shedding hits. Before we get to decoding, let us explore the key similarities and differences between the mid-latitude cyclones you have mastered in our previous interactions and the tropical cyclones you are about to master in our upcoming lessons. This will help erode any kind of confusion that may arise as we're decoding the typhoons. First, let's look at similarities between mid-latitude and tropical cyclones. Well, both are low-pressure celebs, destructive, like that one drunk Malume who crashes every family gathering. They spiral like your WhatsApp status during exam season, thanks to the Coriolis effect. And yes, both bring rain and wind, enough to ruin your picnic date plans. Now the differences. Mid-latitude cyclones? They're the cold front drama queens, bigger than a Your Fees Must Fall protest, 1,000 to 2,000 kilometers in diameter, and fueled by cold versus warm air battles. They are driven by westerlies and are common in cooler seasons. Tropical cyclones? Smaller but fiercer, powered by warm oceans. No fronts involved, just pure summer heat. That's why they are common in warmer seasons. Which cyclone moves westward? Mid-latitude or tropical? Drop it in the comments. If you said tropical, bingo. They're steered by trade winds like your crush sliding into DMs after midnight. We'll dive into the fascinating world of these powerful storms, exploring their general characteristics, how they form, how they behave, and why they can be both destructive and essential for our planet's climate. Next, we'll uncover the areas of formation, where these storms originate, and the different names they go by across the world. Did you know a hurricane, a typhoon, and a cyclone are all the same phenomenon? And finally, we'll break down the key factors that fuel their formation: warm ocean waters, low-pressure systems, and atmospheric conditions that set the stage for nature's most intense storms. Always note the latitude. Mid-latitude cyclones form between 30 degrees to 60 degrees, while tropical ones party between 5 degrees to 25 degrees. And don't forget, Coriolis force is 0 at the equator. That's why hurricanes avoid it like a broken traffic light in Cape Town. Where do they form? They form over oceans hotter than a Durban December. Atlantic ones are called hurricanes. Think Idris Elba in a storm movie. Indian Ocean? Cyclones flooding Mozambique and Mzansi like a Loiso viral TikTok. Over the Pacific? They call them typhoons. Coolest name thanks to the Chinese and Japanese creativity. Australia? They used to call them Willy Willies, but now they got boring and call them cyclones. No creativity, hey? These typhoons don't just come out of nowhere uninvited like your clingy girlfriend. There are conditions which favor their birth. Ocean temperatures at 27 degrees Celsius plus, hotter than a sneaky sundowner. Unstable air rising like your anxiety before a maths test. The high temperature is necessary for the formation of the low-pressure cell and rising air, convection. Friction over the sea is minimal, which also assists rising air. The water vapor content over the ocean is greater, contains latent heat, and this forms the trigger for the full development of the cyclone. It is also necessary for convection and for the release of latent heat as the air rises, and Coriolis forced to spin it up. No spin, no cyclone. Just a tropical depression, moodier than a teenager after data runs out. At less than 5 degrees north and south, the Coriolis force is too weak to promote the formation of the vortex, spiral. Strong winds prevent the formation of a vortex, thus several days of calm conditions are needed for the convergence of air arid the formation of cumulonimbus clouds. This is necessary to maintain a low pressure on the surface and to promote surface convergence. When describing formation, use the acronym WUSH, warm oceans, unstable air, spin for Coriolis force, high humidity. You might want to need to write that down, or you'll regret it like ignoring your new boyfriend's red flags. That's it, GeoMasters. Smash that subscribe button harder than a cyclone hitting land. Next up, stages of cyclone development. See you in the next lesson.